Okay, so now in this video, I'm going to discuss the perfect substitutes, which is um, often common in consumer theory. It might show in exchange economies when you're doing the Edgeworth box. So if you remember from the previous videos, we have a general problem where we're looking for arguments. We're looking for an x and a y that would maximize a utility, which depends on two inputs, subject to a budget constraint. And now we're going to take the simplest possible way. So we're going to replace this with something very the simplest way, which is x plus y. And we're going to make our life very easy. And we're going to say that, let's say the price of x is 2 and the price of y is 1 and my income is 10. So I'd like to solve this particular problem here. Well, the easiest way to go about solving this problem is, well, actually, I'll give you two ways to do that. Here's the first way, which is a non-graphical way. So whenever you see perfect substitutes, which is linear in nature, it might have a constant here. So it might be like ax, by, and of course the prices could be different. The price of x and the price of y could be different. Here's my favorite way of doing it. I could do what is the x max that I can do. So if I spend all my money on x, right, how much utility do I get? Well, I have an income of 10, a price of 2, I can get 5 x's. What is my y max? Well, I have an income of 10, price is 1, I can get 10 of them. So what is the utility that I get when x is its maximum and y is 0? Well, in the previous one that I had, it's 5. Okay, so if I ignore this a's and b's here, okay, just ignore that a's and b's for a second, is 5. And here, the utility of x0, y is equal to 10 is 10. And I can see here that 10 is greater than 5. So I know it's going to be a corner solution where I'm going to spend all my money on y. Okay. Now let's visualize this a little bit differently. Let's do it in a slightly more structured way. So remember, the first step is visualize the budget constraint, where our preferences are non-satiated. So more of x and more of y gives us more utility. So we're going to exhaust that budget. And if y is 0, x is 5, 1, 2, 3, 4, 5. And then if x is 0, y is 10. So I'm going to go 10 up here. 5. So that's my budget constraint. There it is. Okay. And then I'm looking for indifference curves. Okay. So remember, we're trying to get to the highest possible indifference curve subject to that budget constraint. So what about indifference curves? Well, I can think of some indifference curve. Let's say x plus y is equal to 1. That could be one indifference curve. It's representing the indifference curve of utility 1. Okay? And that indifference curve is going to look like this. It's going to be a line. It has 45 degree. So actually all the indifference curves would be 45. That's the indifference curve of 3. Why? Because I go 3 up, 1, 2, 3, right? My x is 3, my y is 3, okay? And from here you could see that, the only way that you would get here, if you want the highest possible indifference curve, is to be at this optimal position. So we will call this the optimal bundle. Okay, we will call this the optimal bundle of x and y. Now let's be more general. So as final thing, let's actually imagine that what we have is a general utility where it's just ax plus by subject to price of x times x plus price of y times y is equal to some money. Okay. Um, And of course, you could still use the way that I showed you, whereas if you spend all your money on X and if you spend all your money on Y, you figure out what is the one that gives you the highest utility, and that's where you put all your money. If it's the same, then you're indifferent along any point on the budget constraint. Okay. The other way to kind of visualize this is to realize that if I plot the budget constraint, I spend all my money on Y, I get M over Py. I spend all my money on X, I get M over Px. I connect this two, I get a negative slope, which is, we've done this in a previous video, which is minus Px over Py. Okay, if you think about the indifference curve, which is Ax plus By is equal to some constant C, Okay. If you think about the slope of that indifference curve, okay, so we kind of do the same thing. What's in, if my x is 0, then the intercept here is going to be c divided by b, okay? Um, Here it's going to be c divided by a, so that it's going to be a linear indifference curve. What's going to be the slope of this indifference curve? Well, it's going to be a over b, negative, since it's a negatively sloped indifference curve, okay? And from there, you can realize that minus a over b is the slope of the indifference curve, okay? Px over Py minus is the slope of the budget constraint. We generally care about the positive values of it, so we can take absolute values and simply compare a over b, px over py. If the indifference curve is steeper, imagine a steeper indifference curve. Well, if it's steeper, you can visualize that the corner solution is going to be where I consume only x. So my x star is going to be m over px. If it's the other way around, if your budget constraint is the steeper one, so basically this is flatter, okay? A flatter indifference curve means that you're only going to consume y. Then your y star is m over py. And finally, what if they're the same? Well, it's any point in the budget constraint, so there's going to be infinitely many, because then you're going to have the same slope, and then the highest indifference curve is going to sit exactly on top of the budget constraint. And there you have it. That's how you go about solving for the perfect substitutes and how you go about visualizing the perfect substitutes. I hope it helps. I'll see you in the next video.